and the due date will be next Tuesday, for the class. So, and the exam will be next Thursday. Whether I was going to change my mind a little bit about 3 days, but let's finish it, because we have enough material for the final. So, we talked about how they can connect. I cannot speak very loudly, there are two types of three-phase transformers. One is like the one I used on the board last class. You have a single-phase transformer, like a three-phase sources. You can connect them, as a delta or as a Y, and you will have a delta Y, YY, and all those kind of things. But let me tell you a little bit about application of this connection before we get more into the detail of the transformer. We have a delta Y and Y delta. YY and delta. These two they are very common and this one also. Delta somehow, not that much, If you look at winding of Y, just look at it. You can listen here, you don't have to, right? So Y, I have a transformer like this, right? This is a Y connection, the Y connection. So, for example, I want to use this transformer in a high voltage, substation. For example, if it's 230 kV or 130 kV, you're talking about kV, there's a big voltage. Look at here, I can connect, let's say we are going to go with 130 kV, for example. One side of the transformer is going to be 130 kV. I can connect it either Y, here is 130 kV, right? Or I can connect it as a delta. If I would have connected as a delta, it would be like this. Right? So this one will be 130 kV. Can you see what's the difference between these two? What is the difference, main difference between these two? How much the voltage over this one? 130 kV, right? How much voltage this one should go? How much is this one? 130 over the square root of 3, right? So, with a star connection, the voltage across the one thing will be not half, but something about maybe 60% of what is with the delta connection, right? Basically, you don't see this problem in the low voltage when you put this wires on. For example, you build the inductor simply like this. You put the wires like this, right? This is a simple inductor. You put the wire on the piece of the core and you wound it up and say, okay, this is the inductor, right? But when the voltage goes up, becomes very big voltage. See, between this wire, there is a voltage, right? If I have 130, for example, here, and this is a 10 turns, for 11 turns, for example, right? Between each of them is going to be 30, 30, 30, 30, it's like 13, 13, sorry, I'm saying 30. 13, 13, 13, right? I have 10, 13 between every two wires. So 13 volts is very small voltage, and there is no problem with the isolation. But when you get to the, for example, 400 kV, so for example, you have a 10 turns, obviously, there is a big voltage between the two layers, right? They call it isolation voltage. Isolation voltage. So in this case, it would be much easier to build it because the voltage is going to be maybe 60% of this voltage, right? For example, here if it is between the two turns is, for example, 10 kV or this 6 kV. So it's much easier to provide the isolation compared to the delta connection. So in general, I'm saying, Y connection needs the less isolation voltage, right? Compared to the delta connection. That's the main advantage of the Y connection. The other advantage of Y connection, usually, they put it like this. For example, they say grounded, the middle point is grounded, somehow it's connected to the ground. Y connection could be with ground or neutral or without, So with the ground or neutral, it's going to give you the fourth wire. So you can supply 3 single phase load, right? Here, can I supply a single phase load here? No, I don't have any neutral, right? But in this case, I can put one load here. For example, this is my neutral, right? I'm going to put one load here between phase and neutral, right? I can put another one here, for example, between phase and neutral here, right? So the Y connection, because of the neutral point, it provides you the fourth wire. You can use it for single phase application. What's the advantage of delta connection? Delta connection, I don't want to get into detail, but especially in the generator, is a very, very good filter for third harmonics. An ideal source, for example, an ideal generator, is going to generate, for example, a sine waveform 10 sine of omega t, right? This is an AC generator. It's generating a voltage like this when it's rotating, right? This is ideal. But all the voltage, all the generators, when they generate voltage, they generate some harmonics. For example, if you look at the voltage, it's going to be something like this. It's not this much bad, but something like this. It's like a steps. It goes on. There are some harmonics in the voltage. There are some harmonics in the voltage. Delta connection is a very good filter for the third harmonics. I don't want to say why, because it's a very long story. But in general, to let you know, delta acts very good as a third harmonic filter for the system. Where do we use YY? As you can see, this is like a three single phase transformer, right? This one with this one with this one with this, right? This is again good for when you have an unsymmetrical load. You have 3 different loads. You can use this one, and you don't saturate it any color. This one is going to work with this one. This one is going to work with this one, and this one is going to work with this one. This is more sometimes you have an unsymmetrical load, and it prevents the saturation. Every transformer, you have 3 transformers. You have 3 transformers, right? You have a 3 transformer, but this one with the other one is like one single phase transformer. This one with the other one is like another single phase transformer, and the same thing here. So this one can work with a different current. This one can work with different current without any interference. But look at here. Look at here. If I have a Y delta, right, and I have an unsymmetrical load here, and I have an unsymmetrical load here. These currents, they are different, right? These currents, they're going to be different, so it's going to end up different current here, different current here, different current here, right? And it may saturate the core. This one it may saturate the core. Somehow it's good because it balances the load overall when you look at it from this side, but it may cause saturation in the transformer core. In general, if you want to know, the Y connection is used on the high voltage side. It's not always. There are cases we use delta for the high side, but in general, Y connection, because of voltage isolation, is used on the high side. Delta is a very good filter for the third harmonics in the system. And now let's get a little bit more to the detail of this 3-phase transformer. So we showed last week how we can connect 3 single-phase transformers either in a Y connection or delta connection, or there is another one we don't talk about. They call it zigzag. Zigzag. I'm not going to talk about it, but that's another connection. So I'm going to start with the vector group. Vector group. Or they call it phase shift. Or they call it phase shift. Or they call it Phasor group. You know, all these names will be used. Phasor group, vector group, phase shift. This is all they can call it that. Let's look at this transformer. Three windings here. Let's call it high voltage side. I'm going to show you with a capital letter. You know, high voltage side, I'm going to use the capital letter for that. And here is the low voltage side. They use the two different standards, you know, to show the head and the end of no winding. Some people they use a dot, and I like the dot, you know, in this way. This is really this way, you know. Or they can use it just letters. They call it, for example, A2, A1, B2, B1. I'm going to give it a dot. I like that for it. A, B, C. And here is A, B, C. So I'm going to talk about the low voltage. I'm going to talk about the YY connection here. So I'm going to connect this one as a YY. So I'm going to connect here. There are different cases. I can connect here, I can connect here, right? So here side I can connect it, right? It's going to be Y. The same thing here and here. But there is only two, overall there is only two cases. I'll show you why. So let me connect this one here to create a Y connection, right? This is a Y connection. You know, we show it here this way because it's easier to show it over the round, you know. But basically, this one over there means this. It means this. A, B, C. Right? A, B, C. Because this one, all they are connected together, and the dots are here. Right? That one over there, I showed it, or put it on the board, is like showing it this way. Right? If this one would be powered off. Now, let me do this. Again, I put a dot here. And you know what does it mean, this dot? What does it mean, this dot? If the positive of voltage is here, here also the positive of voltage is going to be here, right? This is what we discussed before. If I put a dot here, when here is positive, here is, let's say the dot was here. When here is positive, here is negative. So if you are going to show it as a vector, how it's going to be? So if this is a vector, let's call this point N. So if the vector of AN is like this, it's the VAN, right? It's phasor, right? Just like the VAN right now. If the dot is here, right? Let's call this one for now A prime, but I'm going to change it. So if the dot is here, how is the VA? Let me put it here. A prime. What is the direction of A prime? It's going down, right? Because when this one is positive, when A is positive, A is negative, right? So basically the direction of this one is like this, right? Or if I put a dot here, so it's going to be like this, right? It's going to be like this. Now, let's connect this one as a Y1. I'm going to connect these points together, and this is a small, right? When you read a nameplate of a three-phase transformer, they put the numbers like this for you. They put something like this. They put example, y6. Or I don't know, sorry. The first letter is the capital and the second one is the y11, for example. Let's see what does it mean, this number. No, I'm explaining this one. When I see this one on the nameplate of a transformer, I know the primary, the high voltage is the Y connection, the secondary is the Y connection, right? This small y shows this is the secondary, the low voltage, right? And the group, vector group, or phasor group, or phase shift is 11 or 30 degrees. I'll say what does it mean this one. I'm going to explain it. So I want to see what's the, basically we're going to put the nameplate on this transformer. So I should put a Y, right? I need to put the numbers over there to complete this one. Let's plot this one. The phasor, it's going to be VAN, VBN, VCN. Right? Let's plot this one. It's going to be like this. Right? It's going to be like this. Because they are exactly like each other, right? When this one is maximum, this one is maximum. And I'm comparing phase voltages on both sides. Be careful. I'm comparing phase voltages on both sides, okay? Now, the rule is like this. Just let me make sure I'm correct. When you have a block, if you want to say, so this one is we call it, I think, minute hand, right? Am I right? The big one we call it minute hand, I believe, right? Or week hand, I think, right? And this one we call it hour hand, right? Hour hand. Or I think little hand. I think I'm not sure exactly whether I think we call it little hand or small hand. So basically, this is 12. This is 11, right? And we have a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? I'm teaching you how to say what time is it. We're going back to the preschool. So we put the, I just want to make sure I'm saying it correctly. It has been a long time, I don't have a watch now. The minute hand representing the high voltage, vector, right? So for example, in this case, we're going to show this case. So I put VAN blue one, the big one. I put it here, right? Where is going to be the second one? So always we put the high voltage on the number 12. Basically, it's going to be the number 12. Now we'll see where is the little hand. For example, in this case, little hand is going to, if I'm going to do correct color, this one should be like this. Basically, this is a VAN, a capital. And this one is a VAN. So what time is it here? 12, right? Or 0, right? We can say 0 or 12, right? So this one, the connection is Y, 0, or 12. 12 and 0, they are the same. But we don't use the 12, we say 0. Now I'm going to do another case which will not be 0. 0 is very easy, So the vector group of this transformer, I put it on the board, is the capital Y, small y, 0. Means there is no phase shift between the phase. Whatever is a phase in the primary is a phase in the secondary, right? When the number is 0 means exactly they are in the same phase. Now let's change this one a little bit. Let's change this one. I'm going to put the dot. The same thing we have here. I'm going to put these dots here. I want to see what time it is now. Let's look at it. So the blue one is not going to change, right? The blue one is not going to change. This one is going to be VAN. Right? And I'm not going to draw all of them. I need only one. I draw only phase A. No, just I draw it out. Where is the VAN small? Where is this one? Where is this one in this case? Right? Because that's the opposite of that one. You know, I changed the dot, right? It's opposite. What time is it here? 6 o'clock, right? So the group connection, or I don't know, vector group is Y6, right? Let's make it a little bit more complicated. These are the easy ones. So just I wanted you to get a feeling how it's when we say 11, 1, 2, 3, something like that, how these numbers are coming up. So you try, you know, put this one here. I'm going to let it be. I said there's only two cases. Either going to be 0 or 6. There's nothing else. You guys go check it. So you tell me, hey, I'm going to put this one here. Go check it to see what's the group connection. It's going to be one of these two. You know, you practice it and find it out. Now I'm going to do another. Let's keep the primary the same. Or now, you tell me what you want me to try. You know, now let's change this one. Let's put the dots here. Right. This side or that side. Let's put it here. I connect here as a Y. I'm going to connect that with delta. We can get delta. We can connect with this. This is delta connection, right? This is A. This is B. This is C. This is the delta, right? This side is the AB, this one is the BC, and this one is the CA, right? What connection should I do? Let's do the star for now here, right? A, B, C, and you want to know what's the, you're going to have a 1 or 2 in the exam. Now, these are very simple parts, but I ask you to draw the Phasor diagram for this one. So, these are my outputs. Right? What's the connection for this transform? It's going to be D, right? Y. Now I need to find out the number. Right? Let's figure it out. I said you should compare, say be careful what you are doing. You should compare phase A of the high side with the phase A of the low side. Or, if it's easier, you can compare line AB from high side with the line AB of the low side. You know, you should keep it, you know, identical. Whether you cannot select phase A from low side and the line from the high side. You know, it should be either phase phase or line. You know, the phase phase is easier. But let's start this one. So this is basically B, right? This is C, and this is A. This side is very easy to draw. Let's draw this side first. So I have AB, BC, CA, right? So if this is the AB, right? Because dot is on A. Dot is on A. I put it up there. If dot was there, I'll put it down there. You know what I'm saying? If this dot was here, look at it. If this dot was here, I'll say, okay, this is again AB, but this one is here, right? Because the dot is here, I put the arrow up here, right? Where is the BC? Can someone tell me where is the BC? Let me put it here. This is the AB, right? So basically BC should be 120 degrees behind, right? So BC should be here. So this is the BC. And CA should be 120 degrees again here. So it should be CA. Now I need to connect these three three vectors such that B would be on B, C would be on C, right? How about if I move this one here? Huh? I know these three vectors, right? Just I'm going to redraw those three vectors. This is the AB, right? So this is the BC, right? But I don't want to put the B here. I want B here. We want this B letter, right? So I'm going to put it this way. Is it correct? The same vector here, right? Just before, instead of putting it here, just I move it here, right? How about CA? CA is going to be like this, right? Now, why is it this? Can somebody tell me why I did this? Huh? Why I did this? Because I want to find the phase A. Where is the phase A? There is no N, but I put there no fake N here. This is the AN, this is the CN, and this is the VN. Right? Can somebody tell me how much is this angle? How much is this angle? How much is this? 120, right? How much is this? 90. How much is this? 30, right? So basically, I want to find where is the V again. That was my intention, put it in triangular. Because when I have a delta, it's very easy to find the other. Say, okay, here, here. Remember we said delta to store conversion, y to delta. So if this is, so these are my phase voltages, right? Right? If I know this triangular, easily I can connect them like this. Now let's draw the other side. This one was easily settled. So basically, it's going to be like this. VAN, right, because the dot is here, right, is going to be VBN and VCN, right? Correct or not? If the dot was up here, so it would be VAN, VBN, VCN. Because the dot is on the other side, just I rotate them 180 degrees, right? Now, let's compare only these two. I don't care about the rest. My VAN is like this, right? And my VAN is like this. And how much is this angle? 30.